Thank you, concrete repair professional, for the opportunity to tell you about our Resurf joint forming and sealing systems. Feel free to pause to read or study any of the slides. This presentation documents and describes where and when resisted relative movement breaks Portland cement concrete in concrete repairs and offers proven technical solutions to every failure scenario. The literature confirms our calculations using 5.6 times 10 to the minus 6 inch per degree Fahrenheit change as the coefficient of thermal expansion for Portland cement concrete for the minimum allowable expansion. For every 100 linear feet of slab, 0.66 inch or 2/3 of an inch is the minimum allowable expansion. This can easily be a yard per mile or a couple of yards for a runway. Inadequate expansion allowance in one or more joints, usually many more, will result in broken slabs and spalls, usually near joints or corners, and cumulatively sometimes buckles a slab. These are often called hot weather blow-ups. We offer 5 basic systems for Portland cement concrete repair and sealing. The first 2 you see here are unsaturated polyester-based general-purpose polymer concretes. The middle family of Resurf joint forming and sealing systems is described and emphasized throughout this presentation. There will be 5 types of forming materials described in some detail. The last 2 products you see here are epoxy-based for vertical and overhead and wet areas, even underwater. Resurf 2 will be shown in several of the following repairs of bridge decks and joints and various airfield repairs. Note, all of our polymer concretes, feather edge and sawing is never recommended. Resurf LR is a much newer product and will be noted in several repair projects. See the gold sheet. This is something special. Do not saw for this product either. For bridge deck joint repair and sealing, we designate this Type 1. This compares a few very simple steps with many complex steps, ours versus theirs. We will gladly quote and make any type and any sizes of Resurf joint forming and sealing systems. Resurf VO21 is a very user-friendly vertical and overhead epoxy putty which can be used even underwater. Resurf CRE or adjustable wet area or underwater general purpose epoxy systems. This is for eroded culvert bottoms where concrete, galvanized steel, or other can be easily restored. Type 1 is primarily for riding surface bridge joints. Type 2 is for culverts, dams, and levee wall joints. Types 3, 4, and 5 are for airfields and will be emphasized after touching on types 1 and 2. This drawing depicts routinely occurring very poor, let me change that to terrible, surface preparation, and when placing a repair, quote-unquote repair, across a joint or crack. This will never work. It is highly recommended instead of sawing, removing sound concrete, and putting stresses in a plane, time be invested in good surface preparation and installation of our products. Sawing and squaring spalls arbitrarily outside the perimeter of the failure is an antiquated holdover of low-tech, rapid-set mortars and for many reasons is not recommended. Sawed edges put most stresses along a straight sawed plane versus a very profiled perimeter and are somewhat remote from where the original actual resisted relative movement occurred. Rapid set water-based mortars require deeper lifts to hold reaction water and much longer, and have virtually no bond strength. Any quality general purpose polymer concrete such as Resurf 2 or Resurf LR with maximum largest aggregate size no more than 1/6 inch with feather edge to 0 with great bond strength and up to 40 times the wear resistance of the concrete. This drawing shows the basic but essential requirement to prevent the two slabs from breaking one another by separating with low modulus foam board with silicone caulk at the bottom. The high modulus repair material and existing concrete must be separated as deep as practical. This is the first of 9 patent drawings to show how types 3, 4, and 5 are used to effect repairs that prevent 2 or more slabs or repaired slabs from breaking each other. Separate slabs is defined as across an expansion contraction joint, a construction joint, or a crack, even a very meandering crack. Note the location of the heavy bead of silicone or other flexible caulk. It also seals the top of the crack below the foam board. Type 4 easily follows meandering crack trenches made with a chisel bit jackhammer. Short alternating pieces of 2x4 hold in place prior to placing the polymer concrete. Again, notice flexible caulk seals the crack below and prevents mortar from fouling the crack or joint. The caulk also seals against the bottom of the foam and is used to fill voids between the bottom of the foam and the concrete at the bottom of the repair. Repair material on each side of the joint form material must not touch. Type 5 for 4-corner spalls separates 4 slabs. The sequence of Type 5 is first piece carved and placed has slot up, second piece slot down after carving and using black silicone caulk. These could be formed with any combination of types 3, 4, and 5. This is an overhead view of various joint and crack spalling. Here we see typical modes of failure of load transfer mechanisms and shows what also typically happens to the bottom of the slab. Often it mirrors the spall on the top of the slab. Thinner slabs, 6 to 8 inches, benefit from repairing the bottom spall also and running the form full depth where practical. Now we turn to actual photos of Type 1 through Type 5. This is Type 1 for bridge joints. This is a simulated bridge joint repair and seal. Note the neoprene blend seal capped with recessing high-strength cardboard that is sacrificial in a year or two. This is a failed armored bridge joint repaired with Type 1 and Resurf LR. A problem interstate bridge deck, head wall, and approach slab successfully repaired with Type 1 and Resurf LR. Type 2 seals and possibly forms culvert, levee, and dam joints. This project used Resurf VO21 and Type 2. Photo of the same project. Type 3 for straight joints. Of course, the black flexible caulk seals the full length. Most of the foil-lined polyiso foam will be above grade and trimmed after repair is sufficiently cured, but this gives the form sufficient stiffness and straightness. This is just outside an old airfield hangar, and a candidate for Type 3 and Type 5. This shows years of resisted relative movement of this concrete runway slab and high modulus repairs, then asphalt repairs. Excellent reports by Mississippi State University and more recently by Auburn University explain how asphalt-eating microbes destroy concrete. This area, the preceding slide and following slide, show how desperate even international airport runways become. These areas desperately need Types 3, 4, and 5 and Resurf LR. See any FOD prospects? Type 4 has no stiffener. Type 4 showing the necessity of sealing the crack under the repair. Type 4 installed with Resurf LR. Type 4 and 5 installed on an air-based runway with Resurf LR. A chipped out meandering longitudinal runway crack at an international airport. Repaired with a very early version of Type 4 and with Resurf LR. This evolving concept did not utilize silicone caulk. Flexible or silicone caulk is essential. Type 4 and silicone caulk incorporate many technical advantages over these early solutions. Cracks with localized load transfer abused by 1.5 million pound loaded jumbo jets results in pumping and copious amounts of FOD. Remember the earlier "do not do this" drawing? Well, this is an actual photograph at an airbase, scabbed over rubble and gluing the world back together. This black and white of the previous slide shows why you can't solve the crack later. The crack, upon proper excavation here, proved to be at the toe of the guy's boot and not in the middle of the rubble left by the previous contractor. By the way, even if you could follow the meandering crack with a straight saw cut, the thawing almost always occurs a day or 3 later. Guess what's happened during this time? Across a crack or joint and no respect for the integrity of the expansion joint. See the hammer? Guess what it sounded like? Same, and of course, failed. Same, and failed. Damn. Meandering and staggered longitudinal runway cracks do occasionally spawn from some sorts of resisted relative movement, including localized load transfer. To call this a working crack is redundant. They all work, and guess what? They work before sawing occurred. Results are very similar whether temperatures are falling or rising. Maybe we could solve this so resisted relative movement would not exist. Same photo and a red Sharpie to show where to saw, or maybe not. This is a close-up of a meandering, longitudinal, joint staggered runway crack at one of our air bases. We mess up with a capital F when we glue the world back together with a local scab, and when we locally fill in the crack with a substance 3 to 4 times as strong as the old concrete. This is Type 5. Since 4 corners are subject to resultant vectors to yield slightly more thermal growth, These four corners are a great source of FOD. This pretty photo will fix that. If you are seeing this slide and still listening to me, thank you. Polymer Concrete Incorporated was founded in 1984. Our website has numerous service-oriented and problem-solving bulletins, field-developed tips and checklists, case history photos, and very instructional videos. We also conduct classroom and field training with all of our products and techniques. Please contact us by phone or email with any questions or comments, and thank you again for your interest.